All right, today we're jumping headfirst into ecology. We're going to uncover the fundamental rules that connect every single living thing on this planet, from the tiniest microbe to the biggest whale, all tangled up in this huge, incredible web of life. So let's kick things off with a really powerful idea from our source material. And it's this. Even the smallest, most minor shift in the environment can set off this massive, totally unexpected chain reaction. And look, this isn't just some abstract theory. It's a core principle of how nature actually works. And to really see this idea in action, we're going to play detective and solve a real-world ecological mystery. This one question is going to be our guide. We'll piece together the clues to figure out how something so ridiculously small can have such devastating power. Okay, our investigation begins at what is basically a crime scene, a pine forest out in Western Canada. You know, back in the 1990s, this place was just a sea of green. But now, something has gone terribly, terribly wrong. And our culprit, the mountain pine beetle. Our job is to figure out exactly how this happened. But to get what happened in that one forest, we actually need to zoom way, way out. We need to look at the big picture, the huge global forces that literally set the stage for all life on Earth. So let's take a look under the hood of Earth's climate engine. And here is the single most important point you need to get. Climate is the boss. It's the ultimate authority. These big global patterns of temperature and rain are what decide where any living thing can survive, whether it's one little beetle or a massive forest. So how does this engine even work? Well, it's this beautiful, surprisingly simple chain of events. It all starts with the sun, right? Its energy warms up the planet. That creates temperature differences. It's hotter here, colder there. And those differences are what drive the wind and the ocean currents that shape our climates all over the globe. And you can think of it like this. There are three main control dials on this climate engine. You've got the sun, which is the main power source. You have the Earth's tilt, which is the reason we have seasons. And then you've got geography. You know, things like mountains and oceans that fine-tune the climate in very specific places. Now, these global climate patterns, they don't just create one big uniform world. Oh no. Instead, they carve our planet up into all of these distinct ecological neighborhoods. And that's what scientists call biomes. Each one with its own unique vibe, its own character. And what's really wild is that the rules that define these massive neighborhoods are actually super simple. For life on land, it really all comes down to two things: temperature and how much rain you get. And in the water, it's all about how far sunlight can reach and what the water chemistry is like. That's it. It just boils down to those key things. To make this totally real for you, just picture this. You're jumping into a lake on a scorching summer day. You feel that warm surface water, and then, whoa, your feet hit that shockingly cold layer just a little bit deeper. Yeah, that's a thermocline. It's a literal physical barrier that can actually separate worlds within the very same lake, telling organisms where they can and can't live. Okay, so we've got the setting down, we understand the big global forces and the local rules of the road. So now let's take a look at the tools an ecologist would use to investigate a problem like our mountain pine beetle. This is our official investigator's toolkit. And honestly, the best way to think about this is like you're using the zoom on a camera. Ecologists can study life at all these different scales, from a single tiny organism all the way out to the entire planet. And each level of zoom gives you a totally different piece of the puzzle. So for instance, you could zoom all the way in on a single polar bear and study how its body is built to survive the freezing cold. Then you could zoom out a bit to look at its entire population to see how having enough seals to eat affect their numbers. Zoom out again to the community level, and now you're looking at how the bears, seals, and fish all interact. See? Each level just asks bigger and bigger questions, all the way up to the global scale. All right, we have our setting, we have our toolkit, it's time. Let's head back to that crime scene, connect the dots, and finally solve this pine beetle mystery. Now, to solve any mystery, we need two types of clues. So first up are the abiotic factors. These are all the non-living parts of the environment, things like temperature, sunlight, and water. Think of these as the physical and chemical conditions at the scene. And second, of course, you've got the biotic factors. These are all the other living organisms that are part of the story. We're talking predators, food sources, competitors. These are your living witnesses, and in some cases, your suspects. Okay, the verdict is in. Here's what happened. It wasn't just one thing, it was a perfect storm. The key abiotic factor, a small shift in climate led to warmer winters, which meant way more beetle larvae were surviving. The key biotic factor, the forest was packed wall to wall with the beetles' favorite food. So the beetle population just exploded, becoming so huge that they completely overwhelmed the tree's natural defenses. A tiny change in temperature tipped the scales, and the entire ecosystem just collapsed. You know, the case of the mountain pine beetle is just this powerful, sobering reminder of how deeply connected everything really is. A few degrees of temperature change, and poof, an entire forest is gone. And that leaves us with one last big question. What seemingly minor change happening around you right now could be setting the stage for the next profound, unexpected shift?